This lesson is to learn about a way of writing numbers called scientific notation. You can also see it called standard notation sometimes. So it's a way of writing either really big numbers or really small numbers more conveniently. The reason we would want to do this is because basically it saves time and it also reduces the chance for making mistakes when you're writing lots of zeros or lots of digits, lots of decimal places. So here's some examples of places that we see scientific notation being written. So some really big numbers might be distances in space, populations, areas of states and countries, while really small numbers would be measurements of microorganisms or other things that you might look at on a microscope. Certain calculations in science, like when you're calculating concentrations. There's lots of other things, but they're just some examples to give you an idea. Right, so let's go straight into examples of how we do this. So we've got a number written here, a really big number, 16,430,000,000. So the first part of the expression is written as a number between 1 and 10. So basically what this means is we go right to the beginning of the number and we put a decimal point after the first non-zero digit, so between the 1 and the 6. Okay, and then we just write the rest of the number on, so 1.643. The next part of the number or the expression will always be times 10, okay, and then we raise that 10 to a power, so 1.643 times 10. Now the power is going to tell us how many places that we moved that decimal point from the original number. So in the original number, the decimal point was right down here, next to the last zero. Okay, we've moved it all the way in here between the 1 and the 6. Another way of thinking about it is how many digits are there between the new decimal point and the old decimal point. Okay, so you just count those digits. So in this case, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 digits. So that is the power that we raise the 10 to. 10 to the power of 10. And the power is positive for big numbers. And you'll see in the next example that it's actually negative for small numbers. Okay, so here we've written this number in scientific notation. Okay, for our next example, we're looking at a really, really small number. Okay, so after the decimal point there, lots of zeros and then 4, 5, 6. Right, so the first step again is to go to our first non-zero digit, which is 4. Okay, and write a decimal after that 4. Okay, making the first number between 1 and 10. 4.56. Okay. Second thing we do is tack on the times 10. So it's always going to be times 10. And then we raise it to a power. Okay. So again, the number of places the decimal has been moved from the original number. So it was here. We've moved it up here between the 4 and the 5. So you can count the places or count how many digits between the new decimal point and the old decimal point. So in this case, there's 3, 6, 7, 8 digits between the new decimal point and the old decimal point. Now notice here that our power is not just 8 though, it's negative 8 because this is a really small number. Okay, so negative powers mean small numbers. Okay, the other thing that you need to be able to do is write a number that's being written in scientific notation back into decimal form. So here's an example, 4.53 times 10 to the power of 5. Okay, now looking at this, it provides a bit of a set of instructions, I guess, on how to do it. So the power is positive, which tells us this is going to be a large number. Okay, another way of thinking about that is we move the decimal point to the right. When the power is positive, we move the decimal right. The power of 5 tells us that we need to move the decimal point 5 places, or there should be 5 digits between the old decimal point and the new decimal point. Okay, so looking at this number here, 4.53, so there's the decimal, and we're going to move the decimal point right 5 places. So if we move it once, it ends up in between the 5 and the 3. Move it twice, it ends up after the 3. Now we've run out of digits here, so for the last 3 moves, we're going to need to fill that with something, and we fill it with zeros. Okay, so the decimal point was here, it's now here, and there's 5 digits between the old decimal point and the new decimal point, which is what our power was. So this number is actually 453,000. Now I just wanted to make a point here that it doesn't mean write 5 zeros on the end. Okay, it's probably the most common mistake that people make with scientific notation, is they assume that the power is associated with how many zeros go in the number. So you need to be really careful about that, okay? It's referring to how many places you move the decimal point, or how many digits between the old and new decimal, not how many zeros you write. Alright, one last example. So with this one, we've got 6.08 times 10 to the power of negative 4, okay? So because we've got a negative power, that's a clue to tell us that this is going to be a small number, okay? So we're going to be moving the decimal point to the left. Negative power, move the decimal left. The fact that it's a 4 means that we're going to be moving the decimal point 4 places, or there should be 4 digits between the old decimal place and the new decimal place. Sorry, decimal point. Okay, so looking at the number 6.08, so there's the old decimal point. We're going to move it 4 places and we're going to move it left. So that's 1 place. Now again, we've run out of digits. So for the last 3 places, we're going to have to fill with zeros again. This is what it looks like. Oh, my apologies, I've got the wrong number written there, but you get the idea. So that should be 608, and then we've got 0.000. Let me change that now so we don't get confused. Okay, so the decimal point was here, it's now here, and we've got 1, 2, 3, 4 digits between the old decimal point and the new decimal point. Okay, now last thing I wanted to show you on here is how to use your calculator to do this, okay, because you'll find that there'll be some calculations that you'll need to do, and it will be a lot quicker to do it like this rather than to raise it to the times 10 raised to the power every single time, okay. So what we're looking for is the EXP button, if you can locate that on your calculator. Okay, so this button is like typing times 10 and then to the power of, so like your YX button or something like that, okay? That's what it does in your calculator. So if you wanted to enter something like this, 5.3 times 10 to the power of 6, this is what you type. Your 5, your point, your 3, then you type exponential, and you'll notice that what pops up on your screen is a little times 10, and then it's waiting for you to tell it what power the 10 is being raised to. So in this case it's a 6, so you just type 6. 5.3 EXP 6. When you press equals, your display will turn into just a normal number if there's enough places on your screen for it. So in this case there would be. It should say 5,300,000 if you've entered it correctly. Okay, so an example of where you might use it would be a sum like this. Okay, so could be quite time consuming, and if the more buttons you press, the more chance you've got of making a mistake. So using the EXP button reduces the chance of a mistake. Okay, so this is how we would enter it in your calculator. 4.6 EXP3 times 6.8 EXP negative 6. Now notice around that I've put brackets. Okay, so that's important when you're dealing with things that are written like this, with something on top and something on the bottom. So we bracket the top and we bracket the bottom. Okay, so divided by 1.25 EXP13. So if you type that into your calculator, press equals, and we'll see if you've done it correctly. You should see an answer something like that in your calculator. The last thing I just wanted to mention is that you need to be aware of significant figures and how to write them, okay, particularly when you do the work in this chapter. So if you need a reminder on how to round to significant figures, there's a great YouTube video that already exists. So if you just search for this one, How to Find Significant Figures Easy Method, and it's by this guy, Chemist Nate. Okay, he refers to two things in there that you might not be familiar with. One, he talks about leading zeros. Okay, so this means that they're at the start of a number. So I've highlighted those green here. They would be what he calls leading zeros. Okay, the other one is trailing zeros. So these would be at the end of a number. So down here in purple I've highlighted what would be trailing zeros in his videos. Okay, so in this one here. So just so you're aware of that, and if you wanted to go and have a watch of that video, and then you can start your work.